Welcome back. Today we're going to be checking out one of Real Engineering's videos. Specifically this one right here on why Germany hates nuclear power. Since I am prepared that this subject matter might be sad, I brought me a box of Kleenex. Hopefully I won't need it. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge.
This is Germany in the 1980s, before the Berlin Wall came down, still fractured in two between two world superpowers. And this is the map of nuclear power plants that powered the country. The 1980s was an eventful time period for this recovering nation. Chernobyl, located here, just north of Kiev, exploded, showering Europe in radioactive material. The severity of this incident can be hard to grasp in hindsight. Iodine tablets were distributed across Europe.
The whole point of potassium iodine, iodine-131 is a fission product radioisotope, and iodine can be uptaken by the thyroid naturally. So you take potassium iodine as a tablet, so you're going to put a bunch of iodine in you that is not radioactive in order to block the iodine that is radioactive that could come from a radioactive plume after a nuclear accident. Administering potassium iodide is, within the US anyway, can be authorized by the emergency director during a severe accident.
Preventative medicine to ensure the thyroid gland is saturated in non-radioactive iodine, preventing it from absorbing the radioactive iodine present in nuclear fallout, where it could fester and cause cancer. The fallout from Chernobyl spread on westerly winds across Europe.
That's the thing about fallout. One of the biggest factors about how devastating fallout is which direction the wind's blowing. Whenever we did our emergency drills at the nuclear plant that I worked at, our radiation protection manager and their team would look at the weather and do dose assessments based off of that. They had a program that calculated based on what areas were downwind, and depending on how severe the accident and the drill was, we would decide whether or not to recommend sheltering in place, evacuations, a lot of it just based on the directions, and also with sensors to see how bad the radioactive release is.
Spread faster. The people of Europe were afraid.
Local people received 7.4 millirems an hour of radiation.
7.4 millirems an hour, that's a lot for not in a radiological controlled area. It's not going to cause any adverse health effects. Let's see, the threshold for increased cancer risk is 100 millisieverts, so that would be 10,000 millirem absorbed dose, but you don't want to see dose go up on people of the public at all. To give you a sense, 50 millisieverts is the dose limit per year for radiation workers in the United States. You don't want to be seeing any numbers for the public.
Radioactive cesium is recycling in the moss.
Because they are thinking all day about this radiation and nothing more.
The Chernobyl disaster could reap a bitter harvest for the peasant farmers of Poland's far northeast.
If the worst has already happened, the first cases of leukemia should be appearing now.
Chernobyl was given.
That's part of it. Chernobyl was one of the things that the Soviets couldn't cover up because it was setting off radiation alarms as far away as Scandinavia. If you want to hear more on Chernobyl, I highly recommend you check out my reaction to HBO's Chernobyl series. I talk a lot more detail about that accident.
The highest ranking on the International Nuclear Event Scale, a 7, a major accident with a large release of radioactive materials.
So the International Nuclear Event Scale. So here's the International Nuclear Event Scale, and he is right that Chernobyl's at the top, right next to Fukushima, oddly enough, but that doesn't necessarily indicate the level of emergency response by the site or the impact it has on the entire industry as a whole. Because Chernobyl was far worse than Fukushima, and yet this classifies it as the same. And it is classified correctly if the definitions of a major accident and that it had a radiological release and it did cause widespread effects for both. But I would put Chernobyl in a league of its own, because it was, in terms of release, it was over 10 times worse than Fukushima if you look at just how many curies of radioisotopes would release. And also the location makes it even worse as far as the areas that were affected downwind. Whereas Fukushima was right on the water, so a lot of it just went into the water and in a high energy environment got mixed and essentially wasn't a problem, at least compared to Chernobyl. So Fukushima, although it's rated the same, I would rate it at least a tier lower in terms of overall impact. And 3 Mile Island, I would actually rate that one a tier higher because of all the additional modifications that had to be done to all the nuclear plants in the United States, and how it completely redefined how operators were trained, how engineers were trained. Redundant backup systems were designed and further upgraded. Yes, 3 Mile Island, no direct fatalities, no radiological release. That's why it's so much lower. But in terms of overall impact, I would argue it did about as much as Fukushima in terms of industry impact.
In less technical terms, Europe was crop dusted in cancer dust.
That sounds silly.
This event understandably put a big dent into the support of nuclear energy across the world. But this wasn't the genesis of the anti-nuclear movement in Germany. In 1975, 30,000 protesters occupied the construction site of a new nuclear power plant in southwestern Germany on the border with France. In 1979, 7 years before Chernobyl, 200,000 protesters took to the streets of Germany after the 3 Mile Island nuclear disaster in the United States. The anti-nuclear movement in Germany was a grassroots movement, led by the people and driven by fears of the very real danger nuclear energy poses.
Very perceived danger. It fascinates me how everyone protests something, but it's kind of like, okay, a accident at a chemical plant, which can cause arguably worse environmental impact and more immediate fatalities, or like an oil refinery or plane crashes or something, and you don't see people saying we should never run our car, we should never use oil again, or we should never travel by air again.
A tremendous amount of political pressure to begin phasing out these plants, and these protests led directly to the creation of Germany's Green Party in 1980.
And that's where, yes, only time I've ever seen those yellow barrels like that for nuclear waste are in these protests. That's not what nuclear waste actually looks like.
The Chernobyl accident in 1986 simply strengthened the support for the Greens' political ideology to phase out nuclear energy completely. In 1998, the Green Party came into power for the first time, and the true end of nuclear power in Germany was all but secured. It was decided that no new nuclear power generators would be built in the country from then forward. And in 2002, a law banning new nuclear energy was passed. With 2 nuclear power...
That's very sad. Now they're going to have to try to rely on renewables or fossil fuels, importing a lot from places that you'd rather not import from. Very sad.
It's been taken off prematurely in Germany soon after. Angela Merkel and her opposition party, the CDU, called these deactivations destruction of national property. However, in the wake of the Fukushima disaster, even Merkel's opposition to the anti-nuclear movement began to falter. Fukushima is the only other incident in the history of nuclear power that was ranked on par with Chernobyl.
Again, sure that it was ranked on par, but in terms of severity, not even close. Chernobyl at least 10 times worse. I'd argue it's 100 times worse.
Receiving the highest ranking possible due to its impact on the environment and the people of Japan. The Green Party's power in Germany was now at an all-time high.
One thing that's interesting, again, going back to that scale, it just says significant impact. The words are kind of vague, but in terms of deaths, a lot more fatalities from Chernobyl. Chernobyl is anywhere from, I think the official death toll was 31, using, albeit very conservative estimates, taking into account cancer deaths, that can get you up to 4,000 deaths. Fukushima was 4 years after the effect. Keep in mind that that's just from the nuclear part. The horrific tsunami and earthquake, that killed 20,000 people. So that's, again, that kind of puts things into perspective. A catastrophic natural disaster killed 20,000 people and one person from the actual nuclear part. So again, that kind of, I don't like when they say on par. Yes, according to that scale says on par, but that scale doesn't really evaluate the true human impact from nuclear disasters.
Winning control in influential and powerful states in the south of Germany for the first time. Anti-nuclear movement was too large a political football, or perhaps nuclear football, to ignore, and Merkel's CDU party joined the anti-nuclear movement. Nuclear energy had lost this war, and the final power plants in Germany began to flicker out. On April 15, 2023, the final nuclear power plant was shut down.
Again, it's sad. What are they going to do now?
Holding on through the energy crisis caused by Russia's invasion of Ukraine, it finally met its planned end. The images of protesters celebrating the end of their 50-year war on nuclear energy were met with anger and disgust by pro-nuclear activists online.
I don't get it. I really don't get that mindset. I mean, yes, I understand people fear what they don't understand, but the fact that they can wield that much influence is baffling to me.
Merkel's destruction of national property outrage in the early 2000s. How could you celebrate something that so clearly harms Germany's goals of clean energy? Shutting its nuclear facilities has caused Germany to be far more dependent on fossil fuels than its neighbour France. This is what a typical day in France looks like. Baseload is provided by nuclear energy, providing 65 to 75% of the country's power, depending on the time of day.
Nuclear is great at base load, just because of the large amount of production, and it can stay on all the time. It has a very high capacity factor, upwards of 95%. It's the only time you have to shut it down is for a refueling outage every 18 to 24 months. Whereas wind and solar, like, while they're easier to turn on and off, they just don't produce nearly as much, and they don't produce constantly. So the only other way to get baseload is coal and natural gas, and hydro if you're in a region that can support it, but that's a bit more location dependent.
Wind, solar and hydro play their part too, with a small amount of flexible gas-powered plants available to quickly ramp up when called upon, releasing just 30 to 40 grams of carbon dioxide per kilowatt hour generated.
That's not much.
France is in a group of few, an industrial giant, energy independent, not reliant on foreign imports of fossil fuels, and not just powering its own country on low-carbon energy. It also supports its own economy by exporting massive quantities of this power to its neighbours through high-voltage interconnections. A rare example of a country with few fossil fuel resources of its own becoming an energy exporter.
That's just an awesome success story right there, because that's what they did. They used, because you can build nuclear plants anywhere, because you don't need the large amount of resources produced on site. Yes, you do need nuclear fuel uranium, but it is so much more easy to transport, because you don't need train loads of coal coming in, and you don't need long pipelines to bring it in. Nuclear fuel is just brought in at the plant I worked at on a regular semi-truck.
Germany couldn't be any more different. Germany emits around 440 grams of carbon dioxide per kilowatt.
I like the animation he did there.
Due to the fact that 20 to 25% of Germany's power comes from the environmentally disastrous coal.
Coal's definitely the worst. There have been some articles that have been debatable whether or not coal is worth it because of how toxic it is. Is it even worth having electricity with the coal if all you had was coal? That's a bit debatable, but point is, coal's just some nasty stuff. We have enough alternatives to coal that we shouldn't have to use that anymore.
With a further 10 to 15% coming from gas, with the remaining power coming from wind, solar and biomass. While Germany does receive a...
So biomass, basically fancy word for wood and similar stuff. It's your example of something that's renewable but not green. A lot of people like to throw green and renewables together. That's not necessarily the case.
Large percentage of its power from renewables, without adequate energy storage or a nuclear base load, the country has become extremely dependent on fossil fuels. This dependence became all the more apparent as natural gas imports from Russia were cut off, causing electricity prices to skyrocket across Europe.
It's a mess.
This feels like a blatant own goal, a tenfold increase in carbon emissions. Germans aren't ignorant of the damage coal is having on their environment either.
Look at that. I mean, nuclear waste doesn't take up nearly the space of that. And that stuff is a lot more hazardous because it's out in the open and not safely secured in dry cask.
Expansions of coal mines have been protested too, and the Green Party of Germany has been under fire for its vote of approval for an expansion of an open pit mine. If there's ever been an icon of industry-driven climate change, it has to be the colossal bucket excavators that roam this mine. The German government has expressed a desire to phase out coal power soon, but their only realistic option to do that currently is to import even more natural gas. One thing needs to be acknowledged in this debate. Both sides of this argument ultimately want the same end goal: clean, safe, sustainable energy. We are on the same team. The disagreement is on what is considered clean and safe. This exact argument went to the European Parliament in 2022, where France fought for EU legislation to label nuclear energy and natural gas to be labelled green. That second part...
Not sure about natural gas being green. I will say it's greener than coal, but I don't know if I'd call it green.
Seems strange, but natural gas does play a vital role in expanding renewables in the absence of suitable energy storage.
I would say if you don't use nuclear, it's kind of your only option that isn't coal, but just use nuclear.
That subject needs an entire video to itself to explain. This legislation divided the European Union, with 320...
I could explain it. You need a lot of base load to support your renewables. Use nuclear instead of... Your options are nuclear, natural gas, and coal. Pick nuclear.
8 votes for and 278 against. The success of this legislation angered many, with politicians labelling it an odious greenwashing attempt with Macron as conductor. Clearly, this is a divisive issue, and Greenpeace is currently trying to sue the EU over it. But
Greenpeace, that's an example of an environmentalist group that is anti-nuclear and against the best interests in saving the planet.
This legislation paves the way for more countries to emulate what France has done and invest more money into nuclear energy while meeting EU-mandated sustainable energy targets. France, on the surface, feels like the gold standard of climate policy. But let's take a deeper look at how this came to be and the challenges facing France in maintaining this energy policy. For that, we need to rewind 50 years.
Interesting, he's showing all these nuclear plants that use cooling towers. The one that I worked at actually didn't have cooling towers, it just had a massive reservoir. All the cooling towers do is cool the main condenser. Cooling towers exist in fossil plants too.
It's 1973. Egyptian and Syrian forces have launched a surprise attack on Israel on the Jewish holiday of Yom Kippur in an attempt to recapture land on the Sinai Peninsula, taken from Egypt in 1967 during the Six-Day War. Western allies of Israel rushed to support their counter-offensive, and in retaliation, the Union of Arab Oil Exporters embargoed exports to these countries, causing oil prices worldwide to skyrocket. Despite France not being a target of these embargoes, it was a wake-up call for the powerful country. With few energy resources of its own, its economy was extremely vulnerable to outside manipulation.
That's the advantage of nuclear when you have few natural resources such as oil and gas.
Nuclear energy was the answer, and from 1974 onwards, nuclear energy capacity rapidly grew. Over the course of 23 years, France increased its nuclear capacity at an impressive rate, building 56 reactors in 19 different locations.
That is impressive for that. I mean, obviously you're building a lot of them in parallel, but man, I'd love to see that sort of development for nuclear.
However, new builds stopped abruptly in the wake of Chernobyl, with only 2 new reactors beginning construction in the aftermath of this disaster. Chauveau 1 and 2, taking 8 to 9 years to complete.
Well, after Chernobyl, so that bought France a bit more time. In the U.S., it happened right after 3 Mile Island, and 3 Mile Island was 7 years before Chernobyl, so that bought a bit of time.
They came online in 1997 and 1999. These are the youngest nuclear power plants in France, 24 and 26 years old. The oldest nuclear reactor currently is the Bouget 2 reactor, brought online in 1978. It is now 45 years old.
That's a challenge in the U.S. as well. A lot of aging nuclear power plants, but I'm pleased to say that there is a new nuclear reactor that was brought online in 2023. Vogtle Unit 3 and Vogtle Unit 4 will follow suit next year. So we are seeing progress, as well as in other parts of the world, such as the UAE, the Baraka nuclear power station going up.
Its older sibling, Bouget 1, began operation in 1972 and was decommissioned in 1994. It was an obsolete design, graphite moderated and cooled with carbon dioxide. It needed to be decommissioned for safety reasons.
Being graphite moderated does not automatically mean it's unsafe. Chernobyl was unsafe and it was graphite moderated, but what made that one really unsafe was the graphite tipped control rods. There have been other graphite moderator designs that are different from the RBMK design that don't have that weakness. They have some other weaknesses, like their control rods took 20 seconds to hit the bottom as opposed to 2 seconds, like a pressurized water reactor in the United States. But I will say it's less safe than a pressurized water reactor, but to say it's unsafe like Chernobyl, no. Super safe compared to Chernobyl, but less safe than a pressurized water reactor, boiling water reactor in the US.
Nuclear power plants typically have life expectancies between 20 and 40 years.
No. 40 years is the low end. I've never heard of any of them with 20. 20 is like the best case scenario for a wind farm, like a bunch of really nice wind turbines. Those can be lower, like 10 or less. 40 is how long a license is in the United States. Most of them can get extended to 60, no problem. I mean, when I say no problem, I mean compared to building a new nuclear power plant. Yes, you have to do a bunch of engineering analyses and reports and possibly some maintenance and system upgrades, but that is drop in the bucket compared to buying a new nuclear power plant. And a lot of times that license extension is contingent on a bunch of major projects like that, but that is very doable. Going to 60 years, going from 40 to 60 year license extension, very doable. 60 to 80 years even being discussed, that's doable. There have been some out there that could even talk about eventually going to 100 years. We haven't been there that long, so I don't know, but I don't see why it would be impossible. You'd probably have to do a lot more rigorous projects and updates, but 20 to 40, 40, bare minimum, 60 and 80 likely.
Which poses a problem to the French national grid and the European grid at large. I listed every nuclear power reactor in France on this Excel sheet, and I was honestly shocked when I hit the averaging function. The average age of nuclear reactors in France is now 39 years old.
That's younger than the average age in the US, though, well, Vogtle 3 might have brought down that age a lot. When you put in an age of 0, that tends to do that for an average, but median age is probably higher than median age in France for the US.
And these aging reactors are beginning to cause some major headaches in France. In 2022, in the midst of an energy crisis triggered by Russia's invasion of Ukraine, France's energy utility provider, the EDF, was ordered by the country's nuclear watchdog to inspect all plants after a 23mm deep crack was found in a 27mm thick cooling pipe, which circulates low-level radioactive cooling water to the reactor.
So, okay, there may be a disconnect between what he's saying and what he's showing, because this right here is the turbine building in the secondary non-nuclear part of the plant. Or if he's talking about cooling, he'd be talking about cooling the condenser here. I mean, it's possible that, yeah, look, he could be talking about something in the in the primary, but that would be inside the reactor containment building where you're not going to be showing videos of anything. So I can understand why he's showing a picture of the secondary plant. And for all I know, this isn't a nuclear plant, since the secondary plant looks very similar to for a nuclear plant versus a natural gas plant. A lot of times they use very similar types of turbines, very similar types of heat exchangers. Just pointing out that this is a non-nuclear portion of a plant.
The cracks formed as a result of thermal fatigue in a weld seam, where heating and cooling cycles caused the pipe to expand and contract.
Yeah, that is a concern you have to worry about with aging equipment in general. Anything with systems under pressure, piping, thermal stresses, like he said, corrosion. There are program engineers at every nuclear plant that monitor these sort of things, put engineering controls in place, and optimize maintenance schedules for like during an outage of when you need to do these repairs, these inspections, and then evaluate a replacement time thing, just like you would when you're evaluating maintenance on your car. This is just a lot bigger.
This crack could have ruptured the pipe at any moment, and its presence raised alarm bells for the state of nuclear energy in the country. And subsequent cracks were found at other reactors. In the aftermath of these discoveries, nuclear energy output for the country fell to a 34-year low, while these plants were taken offline for inspection and repairs.
Sometimes you have to have forced outages because for maintenance purposes. A refueling outage is typically around 30 days. A lot of times you'll take advantage of the downtime to do maintenance, because you can't do primary system maintenance on a reactor pipe while the reactor is operating, because at least for a pressurized water reactor, it's at over 2200 psi. Kind of hard to repair something under that much pressure. So you shut it down, cool down, depressurize, do the maintenance, bring it back up. But this is relatively rare, because there's a lot of built-in preventive maintenance that happens during an outage that is required, in the US anyway, by the federal government before you actually restart, compared to, say, an oil refinery, for instance, or a gas plant, where a lot of these could just be run to failure. In nuclear, you don't run to failure, at least not on anything in the primary systems.
This problem was a result of decades of underinvestment and mismanagement of nuclear energy in France. And to make matters worse, the technical skills needed to fix the issue have faded from existence in France as a result of the 30-year gap in nuclear energy investments and construction.
That is a real concern with not only in France, but in the US. By the way, if any of you are interested in being nuclear engineers, it'll be pretty easy for you to find a job, because within 5 years, just to maintain the current plants, a lot of people retiring. And if we build more, which we will, there's going to be even more jobs. That's the bright side on that. But yes, big knowledge gap. I remember starting out in my 20s and taking turnover from people in their 50s and 60s. So there has definitely been a gap. It's not going away anytime soon as a new generation of workforce continues to be onboarded, trained. The loss of some of those skills is a concern.
France is now rushing to invest and support welding schools to bring back this important skill, and they need it desperately. Now, just as the Yom Kippur War woke France up to its energy situation, the war in Ukraine and these power outages are encouraging political movement. France has begun a frantic reinvestment cycle into nuclear energy, just a few days after narrowly escaping an ousting from government through an unsuccessful no-confidence vote. A new nuclear energy investment plan won a landslide victory, gaining bipartisan support. The plan will see $56 billion be poured into building 6 next-generation EPR2 nuclear reactors.
I love it.
The first-generation EPR began construction in northwestern France in 2007, over 16 years ago, when the average age of French nuclear reactors was just 21 years old. It still hasn't delivered any power.
Vogtle Units 3 and 4 in the US had a similar-ish time frame. 3's on and 4's right behind it.
And is nearly 5 times over budget at $13.2 billion, a far cry from the $3 billion and 8-year construction time originally quoted.
Yeah, that's the problem with large scale, in addition to some of the skill loss, and it's just people don't know how to do this anymore. So the first time you build it in, let's say, 21 plus years, then I know in the US this was well over 30 years. So people just don't know how to do it anymore. Once we got to get better at it and realize those skills, realize those economies of scale. Small modular reactors is one way to prevent those sort of crazy cost overruns without having to build everything custom. Some of it's regulatory, so you have to, there's some built-in waiting periods, so that can get you the time thing and the cost thing. But yeah, seeing cost overruns like that is sadly not unusual until we get better again.
The second generation design has been specifically redesigned to address these cost and construction issues. The design challenge of making these nuclear reactors safe with all of the knowledge we've gained from accidents over the years is immense. This is not...
That's part of it. All the new modifications isn't why it was cheaper to build stuff versus retrofitting ones with, say, like the post-3 Mile Island, post-Chernobyl, post-Fukushima modifications. So part of it is you're paying a more capital upfront for that, but a lot of it is just the loss of knowledge. That gets expensive, having to outsource to a whole bunch of different countries rather than having to build it on site. That was the big challenge for building Vogtle 3 and 4 in the US.
An isolated incident. This study states that out of 180 nuclear power construction projects, 175 of them overran cost estimations, with an average cost 117% more than estimated.
Part of it is we're not good at estimating either. We just don't know, because we haven't done it in a while.
And taking 64% more time than expected. The latest delay of this new reactor was due to simple welding issues again. When even your welds require specialized heat treatments, requiring specialized skilled laborers, and stringent safety checks, it's going to cause headaches.
Anything with welding is a challenge. He's right in saying that there's a big gap in people that just don't know how to weld anymore.
The reality is, nuclear energy keeps getting more expensive as new safety standards are realized with each accident that occurs.
Looking at this chart, no. So 2011, Fukushima, and he's showing stuff continuing to go up. No, that's going to be inflation driving a lot of that, because there wasn't any significant accident after Fukushima happened in 2011.
Renewable energy keeps getting cheaper. The first of the 6 next-generation EPR2 reactors will not begin construction until May 2027. Optimistically, they will take about 8 years to construct, at which point the average age of nuclear reactors in France will be about 49 years old. Aging nuclear reactors, to say the least.
49 does not cause me to have concerns, because again, now I know France isn't under the Nuclear Regulatory Commission, they have their own thing, they have their own equivalent, but license extensions, which are contingent on upgrades, it's a lot cheaper than building a new one,
are not ideal, posing major reliability issues as we've already seen, but a potential...
Now, because those are all of those are covered in your license upgrade, and anything with safety or reliability will be covered in that.
Actually, disastrous safety hazard too. France is staring down the barrel of major electrical grid instabilities due to decades of underinvestment in nuclear energy. Nuclear
That's
energy,
probably true.
done right, is clearly the best solution to reduce carbon dioxide emissions that we have right now. But the problem is, it frequently isn't done right. So we have to ask ourselves, does Germany have a point?
Frequently isn't done right? No, I don't buy it. I would say it's the biggest challenge facing the nuclear industry, period, is the knowledge gap, and it's more of a hiring and skills development thing. So the solution is turn over as much of that valuable knowledge as you can and bring more people, invest more money into it, which sounds like what they're doing. It's what's happening in the US as well.
Right to close these nuclear reactors down, or perhaps a middle ground between France and Germany is needed. Slowly ramping down nuclear energy, while developing new renewable energy resources.
I can tell it seems like he's trying to be unbiased. I'm not trying to be unbiased, in case you haven't figured that one out yet. But they need to work together, but ramping down to bring up more renewables, no, that's not going to work. Ramping up more nuclear to help bring up renewables, sure, but ramping down is not going to fix anything.
With the energy storage needed to create a stable grid. Or perhaps we need to acknowledge the fact that nuclear energy, as it stands, is not viable long term. And we need to invest in future technologies that make it safer, cleaner, and cheaper. The reactor still under construction in France, as it stands, has a cost of $8 million per megawatt.
The big thing that I think he's missing here for the long term is I think he has that misconception of between 20 to 40 years. So long term, you can keep these guys running while we develop our new technology and more advanced renewables, which I would still like to see, but you can have both. That scarcity mindset has no reason to be there.
While wind turbines cost between $1 and $2 million per megawatt, and critically, they can be installed gradually without having to commit billions to a single project. In a sense, wind turbines are modular, smaller, cheaper, easy to replace.
On the easy to replace, a lot of that isn't recyclable, though. So if you think about environmental impact of all those, like those fiberglass blades and these massive towers, a lot of that is challenging to replace, and it's not as easy to put those up as you may think.
One future tech being worked on right now aims to give nuclear energy this same advantage. Small modular nuclear reactors aim to make smaller reactors that generate less power, but can have additional modules added over time to increase capacity, reducing initial capital investment, making it easier to replace aging modules, and allowing the reactors to be placed in locations not suitable for larger traditional power plants.
Yep, the scalability, you also don't have to refuel those as often. They could even go, some of those can go 5 years.
There are several companies working on these designs right now.
So what are your thoughts? I think it's very sad that Germany fell victim to those fringe groups to get them to steer away from nuclear. It's not based on science. It's not based on real safety statistics. Not based on sound engineering principles either. Again, I'm not against renewables, but nuclear needs to ramp up so we can ramp up the renewables and get off of fossil fuels. I'd love to see more nuclear plants like that period that he discussed in France in the 1970s, that whole period of rapid growth like that. A lot of opportunities to learn, a lot of opportunities. Thank you very much for watching. I'll see you next time.